Hello guys. Okay, so let me just change here with the color. The red will be good. Okay, so this is what's happening right now. So we have an integral, and this integral it's supposed to be performed in cylindrical coordinates. The region is given by the equation x minus 1 squared plus y squared equals 1. And we're asked to evaluate the integral given the cylindrical coordinates. Okay, so the first thing to do is to draw the region in the XYZ space, right? Um, so here it is. This is the region that represents the region of integration. And we see that we have a fair complicated, sort of complicated integrand right here. Square root of x squared plus y squared. And so the first thing you have to do basically is you got to think about what to do, right? You have like two options here when you're trying to perform the integral. One option is to transform the coordinates. Obviously, we're transforming the coordinates to cylindrical coordinates, but however, we could also transform the regional XYZ plane into an XYZ prime space, right? And we can do that by drawing a z-axis right through the center of the cylinder. Now, how do we go from the original to the second one? Well, the way you do it is by just doing a shift in the x direction by the radial distance, right? And that will place your cylinder in right through the middle of the this XYZ space. That looks really cool, and it could simplify. It looks like it could simplify a lot of things. However, I tried it before, and it does not simplify things. It makes the integrand more complicated because you have a square root, and under the square root you have this x squared, y squared, which will be transformed and shifted. The x will be shifted by a specific unit, so that will make two terms inside the x, and it will make a horrible term inside of the square root. So that will make the integrand complicated. One of the things that you have to watch out when you're doing integrals, especially three-dimensional integrals, is you have to watch out with the integrand. When you're trying to do things that will simplify things in your process of integration, you need to make sure your integrand it's easier than harder, right? So I opted out of that option, and so what I did was, okay, well, all I have to do is really find the boundaries of the cylinder in the original XYZ plane in terms of cylindrical coordinates, of course. So I expanded x minus 1 squared plus y squared equals 1, and that led to two equations for r and theta. R equals 0 and r equals 2 cosine theta. The original r equals 0 is not an option, so the only option is 2 cosine theta. So that seems to be the outer boundary for r. So now we rewrite the integrand and the whole integration. We realize that x squared plus y squared is r squared, so the square root of that is r. Now that we multiply that times the other r, which comes from the dB, it makes an r squared. Limits of integration, z goes from negative 1 to 1, and r goes, like said, from 0 to 2 cosine theta, and then theta goes from negative pi over 2 to pi over 2. From there, we do the integration step by step, and then we're left with this term right here, which is cosine cubed theta. Now, this cosine cubed theta, to integrate that, first what I did is a simplification. We noticed that cosine cubed of theta is symmetric about the x-axis, right? So below it and above it is the same. So I just did from 0 to pi over 2 and multiply by 2. Now, if we keep on replacing, if we do a U substitution, we can see that we can get this integral resolved all the way to 64 over 9.